Assalamualaikum warahmatullahi wabarakatuh and good morning. So this is a lecture of gas part 4. In a previous lecture we had learned about the Boyle's law. So today we are going to look at to the Charles law. According to the Charles law, it's stated that at constant pressure the volume of a fixed mass of gas is directly proportional to its absolute temperature, and it can be expressed as V, like this, is proportional to T, or we can make it a constant like this, where we put B as a constant value. V is equal to BT. So in this case, the temperature is not calculated by using the normal degree Celsius unit, but we have to change all the calculation to the Kelvin unit, because as what is stated in the Charles law, it is absolute temperature. So the temperature here should be in a Kelvin. So this is the person who proposed this law. Still, to explain the Charles law, we need to look at to the ideal gas formula. PV is equal to nRT, and if amount of N and pressure are held constant, so the V is equal to nR divided by P times T. And in this case, we can see that V and T are directly related. That means when you increase the V, you also have to increase the T value. So for the Charles law, you need to use the absolute temperature, because from this graph you can see that the volume is here for the y-axis, and then temperature is here. So when you plot the relationship between volume and temperature, you can see it shows a straight line. But after the 0 point here, when you extrapolated the line here, it will goes to the same value or the same point here, where it shows a 0 for the Kelvin, but the value for the degree Celsius is a negative 273.15. That's why when you convert the degree Celsius to the Kelvin, you have to add 273.15, and this is why in the calculation of Charles law, you need to convert all the temperature to the Kelvin unit. And if you look at to this slide also, you can see Charles law and absolute zero. It shows the second law of thermodynamics. Okay, this slide shows a molecular view of Charles law. Okay, we have two containers, one with ice water and the other with filled with boiling water. So as we know, ice water has a lower temperature and boiling water have a higher temperature. Okay, we put the balloon inside this container. Okay, both sides we put a balloon, and we see what happened to the size of the balloon. If you look at to the size, that means we are looking at the volume of this balloon. Okay, so you can see that the particles inside here are still moving because it's a gas. Okay, but the movement is limited because it has a low kinetic energy. But for the second part, the surrounding temperature is higher, so the movement of particles is freely, and the balloon here has a bigger size compared to the balloon in the ice water. So this part has a higher kinetic energy compared to the left hand side container. Okay, let us do this exercise. Okay, a sample of gas has a volume of 2.80 liter at an unknown temperature. When the sample is submerged in ice water at T is equal to 0 degrees Celsius, its volume decreases to 2.57 liter. What was its initial temperature in Kelvin and also in degrees Celsius? So if you look at to this temperature, it shows the 0 degrees Celsius, but to solve this problem, you cannot use directly this temperature. If not, you're going not get the correct answer. So the relationship between these two conditions is V1 T over T1 is equal to V2 over T2. So we are going to find what is the initial temperature for this case. So we just substitute the value given in the question and you will get T1 is equal to 297.6 Kelvin. So remember T2 I have changed into 273.15 Kelvin. You can also use 273 Kelvin. Still acceptable. Okay. So to convert the Kelvin into the degree Celsius, so we minus with 273.15. So the temperature in degree Celsius will be 24 degree Celsius. Okay, that's all for part 4.